How the current? So we'll go for distribution of current. So current I will come. All are identical. All compare the brightness of 4 identical bulbs. So what do you mean by that? All the bulbs will have same resistance. Yes, all must have same resistance. R, and R. Now the current I, so it's as good as like a 4 resistors connected. So don't say if you find very difficult, no, in place of bulb you replace resistance of bulb and work out problem, series, parallel, or KCL, KVL you applied. So current here it will branch out. Current here it will branch out. So call this is I1. Here let this be I2. So then this current I1 will take path like this. So I1 plus I2. And that should become equal to I. And it is like this. No current will flow through this. Anybody? Why no current will flow through the bulb D? Because there's a short circuit path, no? Shall I say it's a shorted? Shorted means not got damaged. The wire will not permit because there's a low resistance path. Here is what? You have a low resistance path. No current will pass through this bulb here. And there's a current I1. See, you should have patience, nothing else there. Just divide the current through all the branches. So why the current I1, why not I1 will branch? There's a low resistance path. There's a low resistance path. So here the current I1 cannot branch here. It's having a low resistance path, so it will take like this. And why not current I? So there's a low resistance path, no, it will go like this. So no current through the bulb D. So bulb not got damaged. There's no current through it. So brightness will be 0. Always say the bulb D got shorted. That's why no current through it. That's why it will not glow. So first thing I'll put like this. Bulb D is shorted. No current through it. So brightness of bulb D is 0. It will not glow. Bulb D. B means brightness I'm taking. Okay, let's come for this one. What about brightness of bulbs A and B? Brightness of A and B should be same, no? Can we compare with C? Anything out to compare? What is the drop across the bulb C? Should be equal to E only. What about the drop across the bulb A and B? It will be E by 2. On what basis I'm saying? I'm asking you to go back and redraw the circuit. This will be the bulb C. The whole circuit now will appear like this. There's a bulb A, B, and C. What all the applied EMF, I think will be shared directly by the bulb C, no? And what all the applied EMF will be shared equally by these two, E by 2 and E by 2. So what is the drop? Drop here will be E by 2. The drop here will be E by 2. Any formula for this? Potential difference formula? Tell me like now. Come for power dissipated equal to power dissipated formula what? V square by R, since we know potentials. So therefore what we can say that which is having more brightness, BC will be greater than brightness of bulb C will be greater than that of A and B. B means brightness. B indicates brightness. Like this, you have to just draw a circle. Still, if you are getting confusion, write R. Here you replace one resistor R in place of this. Here also R. Then work out series parallel one. Let's come for second situation. What happens if bulb A fails so that it cannot conduct? What should be the circuit diagram? what will be the circuit diagram? Bulb A fails to conduct, means it's like an open circuit, no? So where all bulb is there you put open circuit. This bulb B is there still. This is a bulb D, C, and this is B. Now, what is the path of current? Trace the path of current. So current I will take path like this. See, by seeing better, don't go for by seeing and predicting answer. Very simple circuit, you can do it. So what is I is equal to? I equal to E by R. So all the voltage will drop across this one. No? Let R be the resistance of each bulb. Let's assume. So what is the no current? So what is the brightness of the bulb B and D? Will be 0. A will not glow, B will not glow, D will not glow, and then the C will have maximum brightness. Okay, this bulb fails means you have to assume like this. This is the condition. Now, what if C fails? So what if C fails means bulb C make it open circuit. What if D fails? I'll discuss the third case. Okay, third one. What if C fails? So therefore I should show these two bulbs B, A. C fails means put open circuit in place of C. So what is the path of current? The path of current I, this will be I. The current will take path like this. And there's an open circuit, so no current flows in open circuited branch, and this is shorted. So what will happen to brightness of bulb A and B? They'll be equal. Here only let me conclude. Brightness of A and B will be equal. And what is the brightness of bulb C and D? Why bulb C will not glow? Because it got damaged. Fails means what happened? Got damaged. Why got damaged? We don't know. Got damaged, that's all. And this is shorted. There's a different reasons are there. Bulb D will not glow. It is good working condition, but it was shorted. Bulb C got damaged. That's why it was open circuit. Third case, if bulb D fails. Bulb D fails means I should put an open circuit. This is A, B, C, and this is E. Whatever the flow of current, the current again will branch out. I1, say I1, this I2. So brightness of bulb C will be greater than that of A and B. So it got damaged, no? Okay, fine. So these are the some types of numericals what you can expect with the bulbs here. So they just treat them as a register.